ոնց որ սկսենք։ Մի քանի հարց մատ հասկանանք ինչ լեզվով հայերեն բոլորը գիտեն։ Is there anyone who prefer English instead of Armenian? So okay. So there are two options, either English or Armenian. Հայերեն կամ անգլերեն։ Okay. Okay, ոնց որ կան մարդիկ, ում համար հայերեն չի աշխատում, իսկ does English work for everyone? Okay, տենց մարդ չկա, չէ՞ հայերեն չի հասկանում։ Անգլերեն չի հասկանում։ Okay, կա մարդ, ով է network-ի հետ ով կապ ունի, խնդրում եմ ձեր բարձրացրեք։ Okay. Ով կապ ունի network infrastructure, data center infrastructure network-ում այդ ինչ որ բան ասում։ Okay. Tough. Yes, okay, this thing. I'm Alex Saroyan. I'm CEO and co-founder of xCloud Networks. I will tell you about software-defined networking platform which we develop here in Armenia, and we are selling this worldwide. So I will start from the introduction, how we came to this idea. So about 1.5 years ago, I came to a question. I'm network engineer. I have about 15 years of extensive experience in maintaining network infrastructures. So me and my team are managing network infrastructures, building some big networks, some international networks. And I had a question. What we network engineers, what we do besides managing the networks? Because when you look from the side, we are always busy. And I wanted to figure out what is the reason? Why are we so much busy? So this is basically what network engineers are doing every day. So they receive a lot of requests like, please open access between this IP address and that IP address, or assign VLAN to this new port, or configure some circuit, or configure BGP for the customer. So basically, we are doing requests defined by customers, by network consumers, people who require something to be done from the network side. And of course, there are a lot of these kind of requests, that my request is urgent, this is blocking implementation, I'm going to escalate, I know everything right now. So most of the time we are not just building networks, but we do everything what all kind of different network consumers are requesting. And it is not like they are requesting always the right things. This is the problem, and some time ago I wanted to solve this problem. So basic idea was to create a system where customers, salespeople, system engineers, network engineers, whoever requires something related to network, will have kind of one-stop shop portal or something intuitive, where they can go and define all the requests, and that will be applied to on the network infrastructure. About 2-3 months of testing, failing, researching with me and couple of my friends who are here in this room, Arsen and Tigran, we came to kind of concept, and we get clear vision what we are going to do. So we decided to do this, to take a Whitebox switch. Whitebox switch is a network switch which is produced by many vendors, like 7-8 vendors, such as HP, Dell, Mellanox, EdgeCore, and some others. this is kind of open hardware. So this is switch, which is similar to Cisco or Juniper proprietary switches, which is running almost the same hardware inside, the same ASIC. ASIC is the main is the switching silicon, the main part of the switch. And this hardware comes without software. So think about Whitebox switch like a Cisco switch, but without Cisco iOS, without software. So you have API, you can develop your own software, you can install your software on the switch, and this switch will do whatever you want. And all the required features are there on the ASIC. Then we need some operating system, and we decided to use Cumulus Linux. Cumulus Networks are our official partner. We are working with them for about 1 year. Cumulus Networks are our vendor of Linux-based operating system for Whitebox switches, which allows you to develop your software on top of Cumulus Linux. And switch behaves like a usual Linux infrastructure machine. Of course, considering all the special things related to hardware, related to ASIC. And piece of coding. So piece of coding is basically software developed by our company, by xCloud Networks, here in Armenia. So working on this concept, we get to some workable stuff, and which I will show you today during the second part of the presentation. So initial idea was to build a switching fabric consisting from bare metal or Whitebox switches running Cumulus Linux. We decided to use BGP as a protocol for switching, talking to other switches, talking to other switches. We decided to develop intuitive web portal, as mentioned, the portal which was going to become kind of one-stop shop for everyone. And we decided to develop a piece of software which would be working on the switch itself. So initially we have focused on the use case of carrier network. So Internet Carrier is a company who has switches in different parts of the world. So UCOM, for example. So UCOM has network from Armenia towards Frankfurt. So UCOM has network equipment installed in different places of the world. So UCOM is, besides being mobile operator, UCOM is also internet carrier. Kind of example. So this is example of carrier network. We use BGP protocol for the switches talking to other switches. This is not usual BGP protocol. This is kind of a new extension for BGP protocol. It is defined by RFC 5549, but this is not yet supported by vendors like Cisco and Juniper. But fortunately, it is supported by Cumulus Networks on the Cumulus Linux OS and on the QAGA fork maintained by Cumulus Networks. And this protocol makes network engineers' life much easier than it was before, because with this protocol, BGP configuration on the switch is very simple. You just go to switch and tell, I want to run BGP on this port. Then another two switches are doing some negotiation and finding each other. So the BGP neighborship comes up with very simple, just one command configuration, which is very important. It can be either iBGP or eBGP. So rest of the BGP attributes are there. Only difference is with usual BGP, you say that I am talking to this IP address. Here you just say I want to run BGP over this interface. So it works over IPv6. With IPv6 neighbor discovery, two switches find out each other, find out the neighbors. Then they talk IPv6. They establish TCP connection over IPv6.
Switch is прозрачный,
I'll tell about that. It's a layer 3 switch. So with the BGP, we establish connectivity between switches. Then every switch has a loopback IP address. So they advertise loopback IP addresses to the network. So with this approach, every switch knows about every other switch. So every switch can reach every other switch on the network. At this point, we get this reachability. And our software is running inside every switch. Then we have a controller. It's a server, which is also connected to the network. It's, again, reachable through the network. And every switch using our software is connecting to controller, kind of register on the controller. Then switches pull configuration from the controller and apply locally. As well as they collect a lot of statistics and other local information and send to the centralized controller. There is intuitive web UI on the controller, which I will demonstrate and show you at the second part.
Can we have multiple controllers?
Yes. So this is kind of simplified diagram. In real life, there are two controllers, like a backup. So another controller is backing up configuration from first one. So in case of failure of one controller, you have backup somewhere else. And in case connection between switch and controller lost, the software on the switch understands this and handles this normally. So if controller is lost or for some reason unreachable, two controllers are unreachable, only configuration change will not happen. But the rest of the packet forwarding is going to happen because this is compiled deep inside the ASIC. So our software pulls configuration from controller, then compiles the configuration into the ASIC. Then ASIC knows, the switching silicon knows how to forward the packets.
Pull or push?
Push
or switch will pull?
Software pulls, so because it works in distributed fashion. It's a lot of other systems are working other way. There is a controller which pushes configuration to a lot of nodes. Here, because our software is running directly on the hardware, we do other way. We just push configuration from controller. So this gives us ability to run in distributed fashion. And when network is growing, so we can grow horizontally because we don't need significantly more resources from the controller, because we are using resources of the switch.
Can you connect speaker to the switch to play music?
No.
So I think that Cumulus Linux is sort of part of the Linux or networking part only. Is it correct?
It's purely operating system. So it boots on the switch. The switch comes without operating system. We install Cumulus Linux. Like you buy a server, there is no operating system, right? You need to install some operating system, Debian, for example. Then you run your Apache and the rest of your software. So the same is here. We install Cumulus Linux, which is actually paid, but it's Linux. Then our package is being installed on top of the Cumulus Linux, then it runs. It is using system calls of Cumulus Linux, and it is using API provided by Broadcom towards the ASIC. So sometimes we work with the operating system, sometimes we work directly with the ASIC. So as I said, carrier networks. So carrier networks are, what is their business? They are selling circuits. So they have customers who say, I want a VLAN from Yerevan to San Francisco. This customer goes to portal of our customer, see the ports, and say, I want this circuit. So, which is from customer's standpoint a VLAN. But here inside our fabric, VLAN traffic is encapsulated into VXLAN, which is kind of new overlay technology. So we take Ethernet frame, which doesn't scale well. We encapsulate into UDP packet, which is actually IP packet. And since we know layer 3 networks can scale to the biggest scale of the internet. It is same as here. We encapsulate into layer 3 network, and we can scale to the scale of internet.
This L3 is IP addresses of switch or what?
Yes, every switch has IP address, and when, for example, Ethernet frame of customer B enters this switch, the Ethernet frame is encapsulated into layer 3 packet, and it is forwarded towards this switch, which is endpoint for this particular circuit. This switch decapsulate Ethernet frame and deliver to customer. All this happens inside the switching silicon. So this is not making any kind of...
This is L2 connection, yeah?
This is L2 connection, which is as an overlay transported over L3 network. So it's basically overlay network. Like MPLS. MPLS is, again, overlay network. Or like VPN or... So this is type of tunneling protocol. Did I answer? Okay. Because this is used for service providers, we also had a problem of price calculation. So service provider needs basically to charge its customers. And since we are using BGP, we decided that we will use BGP for price calculation. So as you probably know, in BGP, every IP has its BGP is creating so-called AS path, autonomous system path. So since we are running BGP over the network, and as I told, every switch knows how to reach every other switch, this means that every switch knows exact path to every other switch. So we collect this information. Our billing engine collects the BGP information from different switches, and billing engine has visibility of all the BGP topology. Then using this information, we compare with the prices defined by customers, and we are able to calculate the final price. So basically, this customer B wants this circuit from Africa to Amsterdam. Billing engine checks and say, okay, from Africa to Amsterdam, I need to go to, where is it? Dubai, for example, and then to Amsterdam. So these are two hops on the path, and this is derived from the BGP topology.
You use local pref or some prepends or whatever?
The network engineer who is administering this network, he can use local pref, MET, whatever, all kind of BGP attributes for tuning physical behavior of the network, how the packets should be forwarded. To say, hey network, I want to prefer this path over this path, for example, and another path should be like redundancy. Then billing engine checks, looks to the BGP topology table and understands, okay, this is the stable topology, this is the what network engineer wants me to use for the price calculation. And it is always updated dynamically.
So you calculate it manually, and OSPF, for example, gives you all these costs?
Well, yes, but it's different. So we not manually, our software collects BGP topology from different switches. It's different view. Every switch has its own view. So our billing engine calculates all the views from all kind of different switches. Then it compares that with the price. But it's not like the cost like in OSPF. It's a bit different because here you can say I want to sell for this price within this region. So region can be geographical region. Okay, so it's kind of more commercial. And important point was that a company called Sofia Connect, which is based in Europe, became our customer. They are using our platform for their live traffic, for selling real circuits from one country to another country to real customers and charging them for real money, which is being handled fully by our software and hardware.
I'm sorry, if you are talking about this topology, are there your links or you rent it from some provider?
Well, we are a software company. We basically provide software. Then our customer buys software. We provide with list of hardware. Hey customer, this is the list of hardware. Choose what is fine for you. Then customer buys the hardware. We help customer to install our software. Then they build their network. Well,
where you have sockets to connect to your switch?
We don't have sockets.
So this company
This
should buy.
this company is owning fibers and is renting fibers. So they are carrier. They provide connectivity from New York to European major internet hubs and towards Eastern Europe and Middle East. So they have all these links. They own these links or they rent these links. Okay. Well, inspired with this, we decided to go even further and to find more challenges. We decided to look to data center networks because we see a lot of problems in data center networks and we already have a solution for that. So the thing is that during decades, network technologies, network infrastructures were evolving. The network topologies started from old 30, 40 years old core distribution and access. Maybe someone remember this old Cisco style stuff. They evolved to fabrics running BGP or other layer 3 routing protocols. But the point where servers interconnect with the network are still using technologies which are here for 30, 40 years. So we decided to try to solve this problem, to use absolutely different technology, which we are currently patenting. And we've got very good results. So we decided to remove shared segment between server and top of the rack switch. This is old technology. We decided to remove broadcast, lag. We get rid of this wasting of IP addresses because of subnetting, remove VLAN borders, and finally remove this concept of stacking Tor switches. So we don't want two redundant switches to know about each other because this making redundant switches to fail. So in our technology, two switches doesn't know anything about each other. And servers are becoming part of fabric. So this is the fabric which we offer our customers to run. The switches are running same BGP as was previously mentioned, and we run BGP between servers and switches as well. From first look, maybe it looks like it's hard for system engineer to configure BGP, but no, we provide a package which is being installed on the Linux system, and it's very easy. You just install the package, and it comes with default configuration, and you just need to say this is my IP address and nothing else.
Are you restricted only to the Cumulus Linux for the servers?
No, the Cumulus is running on the switches. The servers can run pretty much every Linux distribution, OpenBSD, or even Microsoft Windows.
Is this Quagga closed package?
No, Quagga is open source package.
This company rebuilt Quagga because old Quagga.
The servers are running closed Quagga. For the switches are running closed Quagga. The servers are running a fork of Quagga. Cumulus made fork of Quagga, which is called FRR, free range routing, but it is still open source. So if you want, you can become part of the project and you can contribute. So it's absolutely open source. And what we do, we basically download the source, we add our configuration, we compile it, and make a packet from that and provide to customer.
So every server can have several interfaces.
Yes, you can connect.
So IP addresses or what?
No, the BGP unnumbered, as I talked, is running on every link. So if you have 100 links from one server, all 100 links are running BGP unnumbered. Then you have one IP address on the loopback of the server. So server advertises to the network, hey network, this is my IP address. And network, if network see, I don't know, the same IP address over 10 links, network will use all the links. So it will do load balancing. If link goes down, the load balancing hash will be recalculated and the rest of the links will be used. So it's redundancy without stacking two switches. So if there is software problem on this switch, it will never affect another switch, unlike the staking technology. So this is the benefit of not using staking technology.
Encapsulating here is on the switch.
Here there is no encapsulation. This is layer 3 network. Fabric knows IP addresses of the switches, then packet entering from the internet to the fabric is being routed towards the server.
Why does servers need to know switches addresses?
No, servers receive just default route. So every packet originating from the server is sent towards default route. If there is 2 links up or 8 links up, the server from its side will do again load balancing towards the default route. Okay, this is standard behavior, starting from 4th kernel and standard for Windows as well.
So there is no subnets for servers?
No, there is no concept of subnets, and there is a great benefit with the subnets. Big companies were suffering from fundamental problem. When they want to move server from one rack to another rack, they get this feedback from network engineers that, hey, you know, in other rack you will have other VLAN, you will have other IP addresses and new life. And so moving to other rack means reconfiguring network, reconfiguring server, reconfiguring balancers and firewalls. So with this technology, it's absolutely easy. You move server from this switch to another data center. Everything moves automatically. So there is no need to reconfigure anything.
How two nearby servers can communicate with each other?
There's layer 3 communication. So like this one has /32 IP address .3, and this one has .1. So .1 wants to go to .3. The packet is sent to default route to one of those 2 switches. Then the packet is forwarded towards the destination. It's layer 3 network.
You add the IP addresses of servers to your BGP.
Yes. Here in BGP table, you see every server as a separate BGP record.
If you're removing the subnetting,
Yes.
how can you segment your network?
Why?
Okay. Yeah. Here is another concept. People were segmenting the network for 2 reasons. One reason is because of VLAN borders. This is actually limitation, which we remove. There is no such limitation anymore. And another reason is security. For security, I will show you how we solve this a better way. We do access list. This is actually security part. So we have concept of tenants. We create tenants in our system. I will show you, if there is time, I will show you in our portal how it works. You create tenants. Every tenant can be separate customer or separate product. Then, well, basically there is no access from any server to any server. You should create access list. You should go to portal and say, I want to this IP address to communicate with that IP address on that port. Or you can define more globally, like this subnet to that subnet. And if you request access from one tenant to another tenant, the destination tenant should approve the request. Only after approval, the access will happen. Then how it works technically? Technically, we have the access list information in our database. Then we have location of every server because we have BGP routing table. We look to BGP topology and we apply ACL rules accordingly. Let's move forward and I will show you on the portal more visually how that works. With the BGP in place, we use Anycast for traffic load balancing.
Before you know how it is connected to the internet, I can't imagine how it works.
You have switching fabric.
Yeah.
You can connect your fabric to the internet in different ways. So you can place your border router somewhere here. You can do BGP from the fabric to the border routers. Then you can advertise your prefixes to the internet. So much like with any kind of fabric.
Prefixes,
You-
accumulating.
You aggregate and advertise. So was that your question?
Slash 32.
No, yeah, well, it's basic aggregation. So with the BGP, we can do Anycast, and we use Anycast for load balancing. And we run load balancing checks right inside the switches. Since our software is there, we can develop anything on the switch side. And with the load balancing switches and Anycast, in many cases, we replace expensive load balancing systems. This also works on virtual machines. So we already have integration with OpenStack and Proxmox. Our software talks to OpenStack or Proxmox. These are kind of free alternatives for VMware. So it talks to OpenStack and Proxmox, and when you create virtual machine in one of these systems, we automatically understand that virtual machine is automatically added in our portal. You can do something. You can create ACLs or whatever. So idea, why is this important? Because we want physical servers and virtual servers to be connected to the network absolutely the same way. And this is the only system which can do that. It is important in order to be able to use all this access list, firewalling, and load balancing stuff the same way, both for physical and virtual servers.
For example, if I need a special link between my web server and SQL server,
Yeah.
it should be some link which nobody will see from outside. How can I?
By default, there is no access. You just go to portal, you define access list. You say, this is my IP address of my web server. This is IP address of my database server. I want access on this port. And it will be compiled into the ASIC. And only packets which conform to this access list will be forwarded. The rest of the traffic will be dropped. So we are absolutely secure here. And because of seamless integration, if one day you move your web server from physical server to virtual machine, automatically everything will be applied without any special change. You just move your IP address and new machine becomes like the old one. So we do BGP with virtual machines.
VLANs is needed at all.
No. With this technology, you forget about what is VLAN. Well, almost forget. So, as I said, it works on Microsoft Windows. Maybe for some people it's funny to run BGP on the Microsoft Windows, but first of all, it works. Microsoft Windows has BGP support internally starting from 2012 R2. And 3 weeks ago, I was giving similar presentation during RIPE 74 meeting on Budapest, and Microsoft representatives approached me and they said, what you are doing is great because in our CDN for distributing our Windows updates, we actually use BGP for load balancing anycast, so we use some of these technologies, and we are happy that there is another company who is using this, and this is becoming something useful.
So you can use /32 on Windows?
Yes. With some tricks, but yeah, finally it works. So it doesn't work with IPv6, but we found some tricks using IPv4 link local IP addresses, and eventually it works. All this I will show you in the portal. Innova became first customer who started to use this routing on the host technology. They were previously using Cisco ACI, Juniper, and F5. So they had infrastructure which costed them for about $3 million, and they are currently finishing swapping of their infrastructure, which is right now at this moment with our technology. They are serving 25 million of their customers. They are online gaming company based in Luxembourg and Moscow. So they use this, and this made their infrastructure lifecycle very fast. Before, average change was taking about 2 days from them because everything was being done manually. But today, the similar change is taking several minutes because system engineer moves server just with couple of clicks without involving big number of other engineers.
You have corresponding DNS system to add IP addresses in DNS?
Well, no, DNS, you run separate DNS, but we have other system which makes life easy. Well, I'll show you. So there's still 15 minutes, and I hope I will be able to show the portal. So thank you, Innova.